Hello everyone, my name is Mohit Gupta and today I am going to walk you through my project on model quantization for edge deployment. So we are a team of two, I myself being Mohit and my teammate Shreshth Srivastava. So the motivation behind this is, in today's world we see that deploying deep learning models on edge devices like phones, drones or IoT system is very crucial, but full precision models are often too large and slow. So our goal was to make models faster, smaller and battery efficient. So we wanted to use something known as model quantization. Now let me start sharing my screen. So this is the poster that we have. And now I have already gone through introduction and the motivation behind our project. So if you would see here, we have like a small graph. So we have trained two kind of models. So we have MobileNet V2 and ResNet 50. So we have float point 32 models and the quantized models. And in this graph, we can see that the latency of ResNet FP32 is the highest. Now, I mean, so what we are, so what we wanted to do was, so we wanted to quantize these models and check like whether how good or bad they're performing on an edge device. So some of the key findings that we have are listed here, and we can see that the ResNet 50, which float point 32, had the highest accuracy, but nonetheless, MobileNet V2, which is a quantized model, that gave around 20 accuracy, which is also good. I mean, so this is the top one score, and when we compare it to the MobileNet V2 FP32 model size, we see that there is a drastic drop of about 70%. And finally, we wanted to build an Android app and deploy these models and to test whether the classification was happening correctly or not. So to do all of this, what we wanted to do was, so we went ahead and set up an environment in TensorFlow, and we loaded the data set, which is CFAR10. And then after that, we tried to build model functions. So we built two models, which is MobileNet V2 and ResNet. And then so like we trained it about 75 epochs, and then finally we saved the model, and then like post training we did some quantization, which are these two quantized models, and then we stored them all into TensorFlow light files. In the next slide, I can show you some of the visualizations that we have. So the first graph on the top left is about the model accuracy comparison. We see that ResNet 50 float point 32 has the highest accuracy, but the quantized model of MobileNet V2 and the normal model perform equally well. The training and validation accuracy, so the training accuracy goes to around 90%, whereas the validation accuracy has reached 70%, which is also nice. And as for the training and validation loss, the validation loss spiked up a little in the starting 10 to 15 epochs, but by the end, it came down to about 1.5. And with that, I would like to hand it over to my teammate Shri Srivastava for the demo. Thank you.
So as my teammate Mohit just said, we have deployed the quantized version of MobileNet V2 and ResNet 50 on an edge computing device, an Android phone in this case. So our application offers two features. One is classifying images and the other one is benchmark, which I'm going to show you in a while. So let's start off with classifying the pictures first. Let me first select ResNet 50 and let's classify the ship. And it does come up as a ship. I'll then select MobileNet V2 quantized model and I'll click the picture of this horse and it does get classified as a horse. Additionally, let me also classify one more. So yeah, so this is the classification feature. And now I'll move to the benchmarking model. So here we can select a bunch of images and we can benchmark which model outperforms the other. So as we can see, MobileNet V2 consistently outperforms ResNet 50. There is a spike in the beginning, and that's possibly because of the JVM warmup that happens on the device. So, in conclusion, while more advanced techniques like mixed precision training and pruning combined with quantization do exist, they often require specialized hardware and carefully tuned pruning schedules and fine tuning across devices to preserve model accuracy. This was one of the key reasons why we chose 8-bit post training quantization for its simplicity, reproducibility, and real world deployment on edge devices. So, all in all, quantization does enable deep learning models to run efficiently on edge devices without relying on heavy cloud resources. Thank you.